Hey everyone, Tom here, and this is one of the printers that I got really excited about when it was announced back in mid-2015. And now it's finally here. The E3D BigBox. Now, there isn't just one version that is the big box. You can choose from a plywood or acrylic frame in various color combinations, a full E3D hot end and a heated bed, or an E3D Light 6 and no heated bed, single or dual extruders, and you can add a Raspberry Pi with an improved Pi cam for Octoprint right out of the box if you choose so. In any of those combinations, the big box lives up to its name. It's big, like really big. It doesn't actually need a whole lot more disk space than most other printers with a similar build space of 300 by 200 by 280 millimeters. But having such a tall build space, as well as the fact that the printer is wider than it is deep and uses a box frame, makes it very dominant at the very least. There is a spacious electronics compartment in the bottom area of the machine and plenty of unused space around the actual print area. The big box I have here is actually All3D's early bird Kickstarter machine, which was configured as a Big Box Pro, so it came with the full E3D V6 hot end and a heated bed, and also has the acrylic frame and Octoprint upgrades, still only a single extruder. I personally would have preferred the plywood frame over acrylic and just painted that thing, because I mean, look at the original Ultimakers. Those were all plywood and are still regarded by some as the best printers ever made, at least with the new Plus version. For its mechanical properties, plywood is a phenomenal material, and while acrylic does eliminate the chance of any of the parts warping, it has one flaw. It cracks. There's just no way around it. The inserts E3D uses to create joints between two acrylic parts are probably a good first step as a technical solution, but you still have to be very careful when tightening all the screws that hold everything together. I used my cordless drill as always and had to limit it to the very lowest torque setting, which is around 1 Newton meter, and that's just barely enough to keep the screws from coming loose. This crack right here even opened up just from pulling off the protective film off the acrylic. Also, the inserts themselves were kind of driving me crazy, not only because there are so many of them, but because they each consist of a plastic spacer and a square nut that have a strong tendency of falling apart. Some of the inserts even need to be taped into place because there's physically no way you'd be able to hold them in place during the assembly. And the screws leak their oil coating into the surrounding surface of the matte acrylic. But all that aside, when it's done, it does look absolutely stunning. So yeah, the assembly is an absolute pain to go through and something a novice user would probably not be able to enjoy. This unit was one of the early bird machines and as such wasn't quite as finished as the ones that are being shipped right now and in the future. And while there are still some design choices in here that I would personally disagree with, like how the bed assembly is severely overconstrained, the fact is, it works. Not only was the entire printing experience very consistent and reliable for me, but after installing the latest version of the Z-axis parts, the print quality is also at a very high level overall. I attribute some of the artifacts that are still there to the way Simplify 3D slices the files, but the printing quality you're getting out of the hardware itself is nothing short of amazing. Now, I did ask in the last video whether I should standardize my testing with Make Magazine's test parts, but the problem with those or most other objective measuring methods is that 90% of the quality they're measuring is completely dependent on your slicer settings, and those are something you can tweak and the manufacturer will likely also update as the machine matures. And to be fair, as long as the motion platform, hot end, heated bed and electronics are all solid by themselves, with the right slicer and firmware settings, the printer in its entirety will also print really well. Which is what I try to look out for, since the hardware is not as easily updated over the air as a slicer profile. And in that regard, the big box is well set up. Of course, the V6 hot end and the simple direct drive spring-loaded extruder with an E3D hobgoblin filament drive do deliver a very predictable and consistent filament extruding performance, and the V6 used here even goes a step further and replaces the often criticized thermistor solution with a drop-in PT100 thermal resistor, which overall is a more robust solution and at the same time expands the usable temperature range up to 400 degrees Celsius. So short of melting the aluminum heater block itself, you've probably got a wide enough range there to print even the most demanding materials like polycarbonate or even PEEK. That's what non-all-metal hot ends typically use as a heat insulator. Right next to the hot end is the bed probe, which is a concept I haven't seen before. Instead of going with a mechanical switch or an inductive sensor, the BigBox uses what seems to be a custom reflection-based optical sensor. I'm not entirely happy with its performance as it's highly dependent on your bed surface, so even if you quickly switch from plain glass to transparent hairspray-esque coating, you do need to completely readjust the offset, and since the LCD controller on the BigBox is a completely standard Marlin interface, that's not really too comfortable to do. Speaking of the controller, there are two more things that are bugging me about it. One is the click wheel uses every increment between physical clicks as one input step, something I actually show how to fix in my video about these kind of controllers, and it makes precisely inputting values more difficult than it needs to be. And it also has the rotating direction set the opposite way you'd expect. Easy to fix, but it should be correct right out of the box. And the other thing is the SD slot, from which it is incredibly hard to get SD cards out of. A pair of pliers can help you in that regard, but really the acrylic part should just have a bigger cutout, and I fully expect that a new hardware revision will fix that. Moving on to the heated bed, because it is kind of special what E3D are doing here. Of course, it's got a standard sheet of borosilicate glass on there, clipped to the bed with what looks like clips from a picture frame, not your standard binder clips, and I think E3D's solution works really well here since the clips extend much less above the bed and still keep the glass plate easily removable. But the real star here is the heated bed itself, which actually produces more heat towards the edges of the bed to keep the entire print surface heated more evenly. If you look at thermal images of a classic heated bed with a glass surface, you'll see a pretty severe drop-off in temperature towards the edges, so that concept really makes sense for printing some of the higher temperature materials like ABS. And details like these can be found throughout the entire printer. The dump bucket where the hot end is parked, primed and wiped before every print is one example. The cable spine running from the extruder all the way down into the electronics compartment is another, as well as, thankfully, drag chains for the X and Y axes. The stepper motors for X and Y as well as the extruder are finer 0.9 degree ones, giving the printer an improved positioning resolution over standard 1.8 degree motors without having to rely on microstepping. And there's a ball bearing supported spool mount directly integrated into the back of the printer, which doesn't work perfectly with every spool size, but it can definitely make it work. So you might have noticed I didn't talk about the electronics or linear motion platform yet, and that's for a reason. They're all not really special. At times the BigBox feels like an experiment for how cheaply you can still build a kick-ass printer. The control board, a G-Tech Roomba, is probably the least interesting one you could possibly pick, since it's just the ancient Rambo and an Arduino Mega squashed onto a single board with a few standard Allegro drivers plugged in. It works, but it still uses the same horrible polyfuses from the RAMs and questionable connectors for the supply and heated bed, but it does support up to 3 extruders if you plug in an extra stepper driver. The linear guides are all based on ordinary 8mm rods and LM8 LU, which aren't bad and give a lot of bang for your buck, but they're by far not the stiffest ones and don't really fit the high-spec tagline. So in the end, that value or bang for your buck proposition does work out in favor for the BigBox. Sure, I personally would have liked the components to be a bit more high-endish, but that would definitely have pushed the price up even further as well. At 750 Great British pounds plus tax and shipping, the base BigBox Pro offers good value if you are willing to stem the 10 to 15 hour assembly yourself. But once you start throwing on those add-ons like the acrylic frame, a simplified 3D license, the Octopi kit, or even buy the printer assembled, it does start to lose its edge as it's now competing against machines that are trying to be a bit more of a professional tool than this one. But then again, with the BigBox, you are getting an increasingly fully featured printer. And lastly, the BigBox is also going to be fully open source. Currently, only Kickstarter backers have access to the source files, which are not yet released under a Creative Commons license, so I can't even reshare them at the moment. I guess you'll have to wait for those until all the Kickstarter machines are shipped. And overall, while the BigBox is probably not the best choice for like PLA only casual users, it is a very appealing machine for the enthusiast. The printer offers pretty much everything you could wish for, and there's already a very active community around the machine, even with just a few handful of them shipped. So the platform itself will only be getting better. So that's it for today. Thanks for watching. As always, feel free to leave this video a thumbs down or thumbs up if you enjoyed it. Consider subscribing if you haven't done so already. So see ya, have a good one.